We have been taught in school that the Earth orbits around the Sun, or all planets, including Earth, in the solar system orbit the Sun. Were our teachers wrong about it? Well, not entirely. It is just an oversimplified sentence to make the common people understand the planets and their relation around the Sun in the solar system. But technically, it is incorrect. An object that has mass has gravity. Before we go any further, we need to understand the difference between mass and weight. In simple words, mass is a measure of how much matter in an object. An object's mass is constant in all circumstances. Weight is a downward force caused by gravity on an object. We live on planet Earth and gravity is constant. We can easily convert between mass and weight. But situation changes when we leave the Earth's surface and go into the outer space. Suppose an astronaut weighs 100 pounds on Earth. When he reaches the orbit, he would weigh almost 0 pound. And if for some reason he decides to go to the moon, he would weigh 1/6 or 16 pounds on the surface of the moon. And during this odyssey, his mass, defined by the density and type of atoms in his body, would remain the same. If an object is huge, it has more mass and stronger gravitational pull. Every single object in the solar system exerts a gravitational pull on everything else, from humongous sun to the smallest rock. It is like a massive game of tug of war, and all of the yanking balances out at a specific point, the center of mass or barycenter. Everything in the solar system orbits around that point. Center of mass is the point at which the distribution of mass is equal in all directions and does not depend on gravitational field. Or an object's center of mass is the point at which it can be balanced. Sometimes the center of mass is directly in the middle of an object. For example, a ruler. It could be balanced on one finger by finding the right spot. The other example is a baseball bat. Its center of mass is in the right side, not in the middle, because it has more mass in that area. The location of barycenter between a planet and the Sun depends on planet's mass and its position in its orbit. The barycenter between Earth and the Sun is very close to the center of the Sun because Earth has less mass compared to the Jupiter, that has 318 times more mass than Earth and has its barycenter just outside the surface of the Sun. Our whole solar system also has a barycenter. All of the planets and the Sun revolve this barycenter. It is the center of mass of every object in the solar system combined. Depending on where the planets are in their orbits, the barycenter of the solar system can change from being near the center of the Sun to being outside the surface of the Sun. As the Sun orbits this moving barycenter, it wobbles around. Barycenters help astronomers find planets in other star systems. Planets around other stars, called exoplanets, are very hard to see directly because they are hidden by the glare of the stars they orbit. By studying barycenters, detecting stars wobble, and by using several other techniques, astronomers have detected many planets around other stars. Have you read the Da Vinci Code or other Dan Brown books? Then this fact is interesting for you. In his novels, characters are compelled to uncover mysteries under intense circumstances. The same thing happened to Brown as a child. On Christmas and his birthdays, his parents hid his gifts, requiring him to solve puzzles and riddles to find the presents.